Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you Algebra 1. And in this video, we're going to continue on with Lesson 4, Exercise number 2, where we're going to be solving one variable linear inequalities and then graphing them on the number line. Now, if you're following along in your workbooks, this is found in Chapter 1, Lesson 4. If you don't have a workbook and you're interested in purchasing one, click on the link in the description provided. Otherwise, I'm glad that you're here just watching the video, following along to learn Algebra 1. In exercise number 2, we have solved each of the inequalities below. Then graph the solution set on the number line provided. So the first thing we want to do is we want to solve this just like we'd solve a linear equation, involving one little extra step that we should remember from our previous exercise. And in that previous exercise, we just ended with this new discovery we saw, where if we multiply or divide by a negative number, we should do something. What should we do? If you said flip the inequality, you're correct. If you didn't, maybe you should go back and watch the exercise number 1 video for this lesson. Because when you multiply or divide by a negative number, we want to flip the inequality. That's what we need to take with us when we solve these. So the first thing we're going to do here, as we know from solving equations, is we're going to undo the addition or subtraction first, and we'll subtract 2 on both sides, and we'll be left with 12x is less than 12. Now, we're going to divide by 12 on both sides, and then we're going to arrive at the answer of x is less than 12 divided by 12 is 1. So when we graph an inequality on the number line, we have x is less than 1. So we're going to go to 1 on the number line, and we're going to put an open circle there because it's not equal to 1, it's just less than 1. And then which direction is less than 1? Well, we should know that that's this way. So we're going to shade it that way. You could just draw an arrow pointing to the left, or you could shade the entire number line with an arrow on the end too. Whichever one is your preference is fine with me. On part B, we're going to isolate this inequality, this x variable right here, by subtracting 4 again. And we'll be left with negative 5x is less than negative 10. Our next step is going to be divide by negative 5, and this is where we want to pay close attention because we just divided by a negative number. And when we divide by a negative number, we want to make sure we do something. What was that again? Yes, we want to flip the inequality. So we're going to flip the inequality that's currently less than, it's going to become a greater than, and that will keep this inequality true. And now negative 10 divided by negative 5 will give us a positive 2. Now we have x is greater than 2. Again, a greater than sign is just going to be an open circle above 2. And which direction is greater than 2? Well, that's going to be to the right. I'm just going to draw an arrow pointing to the right. So this could be any number that's greater than 2 would be a solution to this inequality. Going on to part C now, this is the first time that we're seeing a or equal to inequality. So this one in this case is greater than or equal to. And again, I'm going to move all my constants to one side and my variables to the other. I have all my variables on the right, so I'll keep them there. And I'm just going to move this minus 1 by adding 1 to both sides. I'll have 8 plus 1 gives me 9. It's greater than or equal to negative 3x. I'm going to divide both sides by negative 3, and there it is again. I'm dividing by a negative, which means I want to flip the inequality. Yes. So 9 divided by negative 3 will give me negative 3, flipping my inequality from less than or equal to x. Now this is actually read as x. Which side is facing x? The greater than side. So this is actually x is greater than or equal to negative 3. So now that it can be equal to as well, you want to shade in that circle. We're going to have a closed circle to show that it includes negative 3. And which direction is greater than negative 3? Well, that's going to be to the right. And again, just an arrow pointing to the right is perfectly okay for that solution set. And in part D, we have a couple more steps involved. Again, we're going to look for addition or subtraction outside the parentheses. I see this 4 that needs to be moved. And again, it's a positive 4, so we're going to subtract 4 on both sides. And we're going to be left with negative 2 times x plus 5 less than or equal to negative 6. We're allowed to subtract. That's okay. It's when we're multiplying or dividing by a negative number is when we need to be careful. So subtracting is okay. We don't have to do anything with the inequality there. And then we're going to look at what we do next. But before we do that, I want to go back up here. And if you saw this 4 minus 2, and you wanted to subtract the 4 minus 2, we're not allowed to do that. That would violate our order of operations, and that's not allowed because this 2, this negative 2, is being multiplied by everything inside here. And multiplication or division comes before addition and subtraction in our order of operations. So we cannot subtract these before we multiply this. And that's why we do not want to combine this right here. We want to go about this by subtracting the 4 to the other side first. And now we're going to undo that negative 2 by dividing it on both sides. And we want to be especially careful there because we're dividing by a negative, which means we have to flip the inequality. Catching on, right? Now, negative 6 divided by negative 2 is a positive 3. So our x plus 5 is greater than or equal to 3. And our last final step here is going to be to subtract 5. And we're left with x is greater than or equal to negative 2. So it's an equal to inequality. So it includes the number negative 2 in our solution set. We're going to put a closed circle there then. And which direction is greater than or equal to negative 2? Well, that's going to be to the right. And I draw an arrow to the right of this closed circle here. And one more for this exercise. We're going to have variables on both sides of our inequality now. So the first thing we want to do is now in this case, we do want to distribute. Because if we were to divide by 4 on both sides, we'd be dealing with fractions, which is okay, then it is possible. But to make my life a little bit easier and yours, we're going to distribute that 4 to everything inside the parentheses. So I'm going to be left with 5x plus 7 is greater than 24 minus 12x. And now I have a simple inequality with variables on both sides. I want to move all my variables to one side, all my constants to the other. So I'm going to start off by subtracting 7 over here. I'll be left with 5x is greater than 24 minus 7 will give me 17 minus 12x. I want to move all my x's to the left side of the inequality, so I'm going to add 12x because it's currently a negative 12x. And 5x plus 12x will give me 17x is greater than 17. And my final step would be to divide both sides of this inequality by positive 17. So I'm going to have x is greater than 1. So now that I'm going to graph this on the number line, again, if it's just greater than, it's not including. So I'm going to put an open circle at 1. And the greater than direction is to the right. So I'm going to draw an arrow pointing to the right of that open circle. So if this video was helpful in solving one variable linear inequalities and then graphing them on a number line, give it a thumbs up by clicking on the thumbs up below. You are now ready to go on to the next lesson in Chapter 1, which is Lesson 5. And you can access that by clicking on the link in the video provided. Thank you for watching.